So, welcome to the video lecture series on theory of computation. In today's video lecture, we will be learning about Kleenes theorem. The Kleenes theorem is a very popular theorem which has three cases. The first case is if the language is getting accepted by finite automata, then it can also be accepted by a transition graph. So, the difference between finite automata and transition graph is for every single input symbol, we have to make a transition in finite automata. Whereas transition graph will actually take a string as an input and it goes actually to the final state. So, that is the only difference between finite automata and transition graph. And the second case is if the language can be accepted by a transition graph, then it can also be expressed by a regular expression. And the third case is if the language is getting accepted by represented by a regular expression, then it can be accepted by a finite automata. Now, we will try to solve case number 1 and 3. We will try to prove this theorem. Now, the first case is if we have a finite automata, then if the language is represented by finite automata, then it has to be accepted by transition graph. Now, we will take this theorem now. Now, if the language is getting accepted by finite automata, then it can be also accepted by transition graph. Let us see here. Now, I will take an right tool here. Now, let us assume that I have S. So, technical issue here. Okay. Now, let us assume that S is equal to ABB. Okay. This is a string in a language L. So, this S actually belongs to a language called as L. Now, I want to prove this. Now, I understand that what is the input symbols? You have two input symbols called as ABB. Now, that means sigma is equal to A comma B. Now, we will try to draw a finite automata for this specific string. Let us assume that we start from the state called as Q1. Q1, when A is applied, it goes to Q2. Now, it goes to Q2. Now, in Q2, we are standing now when B is applied, we go to Q3. So, when B is applied, it goes to Q3. In Q3, when again B is applied, that is going to be the last string. So, we go to a final state called as Q4. Now, this diagram is called as an NFA. Now, how will you make this as a DFA? DFA means both inputs has to be applied A and B. Now, in Q1 only A is applied. So, when B is applied, I actually move to a trap state. So, we try to move to a trap state. So, now when B is applied, we move to a trap state. In Q2 only B is applied, A is not applied. When A is applied, we move to a trap state. In Q3, B is applied, A is not applied. So, when A is applied, we move to a trap state. And Q4, none of the symbols is getting applied here. So, now I make a trap state for A comma B. Okay. So, now this is called as a DFA. Now, how to just convert it into a transition graph? So, the difference between finite automata and transition graph is for every input symbol we make a transition in finite automata, but in transition graph we will make a whole move. Entire string will be read. Now, what is the valid string? So, the valid string will make a transition graph here. The valid string is actually ABB. So, this is called as a valid string. Now, I immediately go to a final state called as Q1 and the final input which is input applied here is ABB. Now, this structure is called as a transition graph. So, this entire structure is called as a transition graph. Now, on top of it, what you see here is called as a DFA and this is also called as a finite automata. So, this is the way of proving this. A finite automata can also be accepted by a transition graph. Now, we will just go for the case number 3 now. So, case number 3, I just here. So, case number 3 is if the language can be represented by regular expression, then it can also be accepted by finite automata. Now, we will go for this. and null page. Now we take a regular expression. Let us assume that I take a regular expression called as R is equal to AB, and next you have A, and after this you will have A plus B whole star. Okay, and after that you will have B. Okay, now what is a valid string here? So we will have a valid string called as, out of this A and B, A may appear. Now the next second input symbol is A. Now third input symbol can be, may or may not be appear, and fourth input symbol is B here. Okay, now the first input symbol is B, second input symbol is A, third input symbol is A or B. We will have A now, and fourth input symbol is B. So it will go on appearing like this. Okay, now this has to be represented in a form of finite automata. So how to represent that in the form of finite automata? So now this is called as a regular expression. So I will just apply the direct method here. I will apply the direct method for representing this. So direct method. So instead of going for subset method, we will go for direct method. Now subset method will be a little bit lengthy. We will go for the direct method. Now direct method is now we will start from the state called as Q1. So in Q1, I have two possibilities, either I can give A or I can give B. So now when I go to Q2, there are two possibilities, either I can apply A or B. Okay. Now in Q2, there is only one possibility, that means I can apply only A. So I go to a state called as Q3. So now only one possibility is A. Now in Q3, now A and B has to be repeated 0 or more number of times. So that means I make a self loop here. So A comma B can appear 0 or more number of times, but after this I have to apply B. So when I give B, it has to go to a final state. So I make Q4 as a final state. Now when actually B is applied, I go to a final state. Now you can see here that this is completely represented with the help of finite automata. Okay. So a finite automata can also be represented when a regular expression is given, it can also be represented in the form of finite automata. Now see here, now this is only a finite automata NFA, but if you want to make this as a DFA in Q1, so what is the input here? Input is epsilon is equal to A comma B is given as an input now. Now in the first case, both A and B is getting applied, so no issues. But in Q2, we are only applying A, we are not applying B. Suppose in Q2 if B is applied, definitely I have to move to a state called as trap state. Okay. In Q3 both are applied, A and B are applied. Okay. So this should get repeated. Okay. In Q4 you can see here that nothing is getting applied here, so we will try to move this as A comma B. Okay. So thanks for watching the video. Have a good day.